All right, this is just a real quick addendum about some calculator use. So in the lesson you just watched, you saw that all of our intersections turn out to be integers, nice numbers. But what happens if they're not? And what's an easy way to deal with that? So if you do find your intersections and they turn out to be, decimal answers that are not necessarily easy to write down, remember, you don't want to do intermediate rounding. So what happens if that's the situation? So I wanted to kind of quickly go through something like that. So here we're going to deal with these two functions here, y equals x squared plus 3x, and y equals the square root of x plus 5. So as you can see, we're dealing with this region right in here. And as you can see, where they're intersecting is clearly not at integer points. So let's go ahead and deal with that real quick here. So I'm going to type these functions in. So I have x squared plus 3x, and then our second is square root, so second square root, and then x plus 5. And we're going to go ahead and do a zoom standard, and there's our graph. Okay, so once again, we're going to go ahead and do our second calc to get our intersect. That's our 5. First curve is a y1, good, enter. Second curve is y2, good, enter. And for our guess, again, I want the one that's over here, kind of close to -3-ish. And it turns out to be negative 3.377203, and it probably goes on much longer than that. Now, we are going to have to use that as our lower limit. And you could write it down, but there's an easier way for us to do it. So because it just now solved for that, this is now currently, as far as the calculator is concerned, this is now currently the value for x until it does something else to solve. So I'm immediately going to go to second quit to return to this screen, and I'm going to now just hit my variable button x and hit enter. And notice that it calls up that value. And so now what I can do is I can store that value. So I'm going to hit the STO button right here above on, and that's going to store the last value it showed. So it's going to store this negative 3.377 blah, blah, blah. I'm going to store it as A. So I'm going to hit alpha A and enter. And so now anytime I want to refer to A, if I just hit alpha A and hit enter, it's going to call up that value. So now let's go ahead and go back to our graph. Let's find our B. So we're going to do our second calc again to find that second intersection. First curve is y1, second curve is y2, but this time my guess is going to be closer to 1. And so we get 0.6510931. So again, that is now the value of x as far as this calculator is concerned. So I'm going to go back to this screen and I'm going to hit x and enter. And now it's going to show that new value that it found. And I want to store this as B. So now I'm going to hit store alpha B and enter. So now the calculator knows that that's our B. So now if I want to do my definite integral, I'm going to do math 9. Remember, my lower limit is A, so I can actually hit just alpha A. And it knows that I want the negative 3.377. Move up to the upper limit, alpha B, and now for my integrand, remember the trick that I showed at the end of the previous lesson. If I look at my curve, I can see that the square root function, which was my y2, is my upper curve. So I'm going to do vars, y vars, function, and I want my y2, minus my y1. So again, vars, scoot over to y vars, function, and I want y1. And then finally I can put my dx. So look at how compact this whole definite integral is. I didn't have to type in a single number here because the calculator already has all of that information and it's just going to substitute for us. And then I can hit enter and there is our answer. Okay, so that is a trick that you can use with the calculator that can potentially save you some time on an AP exam. All right. Good luck.